Today, we're diving into something pretty amazing. We're talking about how agriculture, one of humanity's oldest industries, is getting a massive upgrade from one of our newest tools, machine learning. We're going to break down how lines of code are helping to predict the future right from the farm.
And really, it all boils down to this one huge question. Can a line of code actually help feed the world? It's a big promise, so let's see if the tech can back it up.
So, here's how we're going to break it all down. First, we'll talk about the big risk farmers have taken for centuries. Then, we'll see how data is changing the game. We'll get into the nitty-gritty of how these predictions are made, peek under the hood at the tech, and then look ahead to what's next for the farm of the future.
To really get why this new tech is such a big deal, you first have to understand the problem it's trying to solve. And honestly, for thousands of years, farming has basically been a giant gamble.
Just think about it for a second. A farmer has to deal with, well, everything. The weather is all over the place, the soil can change from one field to the next, and there's always that risk that the crop could just fail. A bad year isn't just disappointing, it can mean huge financial losses, all because of things way outside of their control.
But what if you could stack the deck just a little bit in the farmer's favor? That's exactly where this modern approach comes in. It's all about shifting from relying only on gut feelings to making decisions backed by real data.
So, say hello to the crop yield prediction system. Okay, what is that? At its heart, it's a machine learning tool that looks back at years and years of data. We're talking rainfall, temperature, soil types for a specific area, and uses all that info to make a really educated guess about what the next harvest is going to look like.
And this right here shows you the big shift. On one hand, you've got traditional farming, which is an art, right? It's all about experience passed down through generations, intuition, a gut feeling. Now, data-driven farming doesn't throw that away. Not at all. It actually supercharges it. It adds this layer of predictive modeling to make those experienced decisions even smarter. So what's the end goal here? I mean, it's about more than just spitting out a number. Think about it like this. A farmer, say, in Iowa, gets a prediction that it's going to be a dry year. The system might suggest a different, more drought-resistant type of soybean. Making that one switch could boost their yield by 15%. I mean, wow, that's a game changer. It's all about helping them pick the right crop, cut down on losses, and farm in a way that's both smart and sustainable for the long haul.
Okay, so how does this thing actually work? How does it go from a bunch of old weather reports to a useful prediction? Let's pull back the curtain and walk through the 5 main steps.
All right, first up, you gather the data. Decades of info on crops, climate, soil, everything. Step 2, you have to clean it all up. That's called pre-processing. You're basically getting it ready for the main event. Step 3 is where the magic happens, model training. This is where the system learns all the hidden connections in the data. After that, in step 4, the trained model makes its prediction. And finally, step 5, you have to show that result in a way a person can actually understand and use it.
And this is a perfect way to think about that third step, the training part. It really is like teaching a student. You just keep feeding the algorithm thousands of examples from the past. Like, okay, this much rain plus this kind of soil led to this much corn, over and over again until it starts to see the patterns for itself. Then it can make a really smart, educated guess about a future season it's never even seen.
So, what's actually running this whole thing? What tools are the developers using? Let's pop the hood and take a look.
Okay, the toolkit here is pretty much the gold standard in the world of data science. And for good reason. It's incredibly powerful and it's all open source. The main language is Python. Then you've got libraries like NumPy and Pandas, which are workhorses for handling huge amounts of data. For making charts, there's Matplotlib. And the engine driving the whole thing, that's scikit-learn, which is packed with all the machine learning algorithms you could need.
And hey, if you had any doubt that this is a data science project, check this out. This is from the actual source code. A massive 98.9% of it is built in what's called a Jupyter notebook. If you've never heard of that, just think of it as an interactive sketchbook for data scientists. It's where they can write code, immediately see the results, and build their models all in one place.
Now, I know this can all sound a little abstract. Code, libraries, models. So let's make it super concrete. What does this project actually look like as, files on a computer?
Here they are. These are the 3 core building blocks. You've got the code file itself, which has all the instructions. Then you have the data, the CSV file, basically a giant spreadsheet with all the historical info. And finally, you have the trained model, that's the .pk file. You can think of that as the brain that's already learned from all the data and is now ready to make predictions. This is already so powerful, but honestly, it's just scratching the surface. So what's next? Where can this technology go from here?
Well, the possibilities are really, really cool. I mean, imagine hooking this up to real-time weather feeds, so it's not just using old data, or using even more advanced deep learning models to get even more accurate. You could build a simple app that any farmer could use on their phone. Heck, you could start pulling in data from satellite images or even sensors right in the soil. The system is built to get smarter and smarter.
Because really, the ultimate goal here is so much bigger than just one harvest prediction. It's about giving an entire industry the tools it needs to be smarter, more resilient, and truly sustainable, especially as our world and our climate keep changing.
And that kind of brings us full circle. We started by asking if code could help feed the world. But maybe the better question to leave you with is this. If a little bit of code can help optimize something as ancient and complex as a farm, what else can it help us grow?